Oh, that's a Simon Garfunkel song.
Yes, it is.
Oh, I didn't know that's what you were singing to. Welcome, Abyssers, to calculus. We'll get started right away. We're talking about parametric equations, and hopefully, I'm going to give a shout out to Ray, who has told me how to run my machine here, so people can hear me, because Maggie was saying, "Hey, I couldn't hear anything you say." So thank you, Ray. He helped me out. So that is probably 6,000 mental extra credit points. Okay, and that's real applause. It is not, the canned applause you hear on Big Bang Theory or anything like that. Now I'll get all this hate mail from people that love Big Bang Theory. Alrighty, so we have I talked about this relationship, Jack Lukanen, that dy over dx is the same as dy dt over dx dt, as long as dx dt does not equal 0. I'm thinking that would be a bad thing.
Yeah,
right? Do you see that? I probably should say this. I should cross that out. And I'm going to get a different pen. Dx dt. As I was looking at these notes, I found a lot of errors, so I'll fix them for you. I don't know what was happening when I was doing those errors. So, are we okay with that, folks? Does that make sense? All right, so we're given two parametric forms, and Maggie's not here, so we're going to start with Matt. Dx dt, what is it?
Would be 1/3 t to the negative 2 thirds.
Okay, or it can be written like this. So it's a 2 cubed. Is that okay, Matt? Mm-hmm. All right, dy dt. What is that, Nate? Negative 1. So dy dx is what, Noel?
Negative 1/3 t, well, like negative 1 over 3 t to the 2/3.
Isn't it this?
Oh, yeah.
Is that correct?
Yeah.
So that's this. And so when t equals 1, what would I have here? When t equals 1, what would dy dx be? Noel. What are we having for, is that lunch?
No, just yogurt.
You already had lunch?
Yeah, but I didn't like it, so I got it.
Oh, you didn't eat a full lunch because it wasn't tasty. It wasn't tater tot hot dish, was it?
No.
Good. Because I wouldn't want you to suffer in that manner. What is it?
Just -3.
Negative 3. Right? In fact, we could do this. We could say that x cubed is equal to t. Right, Jack? All I did was cube both sides. And that means y equals 4 minus x cubed. That would be the rectangular form. That means dy dx would be a negative 3x squared, correct? And if t equals 1, that means x equals 1. So I'm just verifying that negative 3 is the answer in another form. Are we okay with that? All right. Now, this is the part that's messed up. And so I'm going to redo this. And the question is, what is the second derivative? And everything is, this is wonderful that the second derivative, and I remember having a large discussion with this point with Jeremy Flipson. So if he's one of my followers, which I don't think he is because I think he's too busy. But we talked about that. This is not a power. It's just saying you're taking the derivative. Okay? So just for a little bit of review, if I have a position function, its derivative is the velocity function, correct? The derivative of the derivative, or the second derivative, is acceleration, which if I have miles per hour, or excuse me, let's go feet per minute, the acceleration is feet per minute, right? It's how the velocity is changing every minute. Does that make sense? So when I write it in this form, this is where we are taking the derivative of the first derivative. Does that make sense, that notation? And it says, however, dy dx, since it's parametric, is dependent on time. And everything's good up to this t. Then everything is a mistake by me. Okay? So what I'm going to do is do what I always do when I make a mistake. I scribble it. So I'm going to scribble everything to here. And I'm going to view it like this. If this is the second derivative, I'm going to do a little bit of algebra here. I can multiply it by 1, which is what dt over dt is. And since in fractional multiplication, you multiply straight across, correct? Order does not matter, does it? In other words, 3 times 2 is the same as 2 times 3. You could probably get both those wrong writing 5 for either one, right? Okay. Which I've done, and somebody in today's quiz in AB did that. So I don't know if they're watching. So I can write this in this fashion. I think that's okay, right? And here I'm multiplying by a fraction. Well, really, this is the reciprocal of a division problem, isn't it? So I can write this as the derivative of dy over dx, and of course I never give myself room, divided by yeah, I switched it already. It should be dt. Thank you very much. Okay. And right here, this should be divided by dx dt. So this is equal to the derivative of dy over dx over dt divided by dx over dt. So in other words, I have to take the derivative of dy dx with respect to t and divide that by dx dt to find the second derivative with respect to t. So t will be my input value. Okay? So let's go back to this one and say, all right, if possible, let's look at the concavity of this relationship. So again, we had x equals t to the 1/3 power. I know I wrote it as a cube root, but I'm going to write it that way. And that y equals 4 minus t. And I believe Matt said this was 1/3 t to the negative 2/3, correct? Okay. And that means
That's one bit, right?
pardon?
That's dx dt.
Well, it's dx dt. Thank you. Okay. And so then dy dx was equal to a negative 3, correct? Right? That's what we said, right? dy dx was a negative 3, right? Okay. So if I take the derivative of this, with respect to t, what do I get? I get 0, because the derivative of any constant is 0. Yes, sir.
So why did you, for dy dx, use the one with value t equals 1 instead of just your one with t already in there? Why'd you plug 1 in for? Yeah, because we have negative 3t to the 2/3 is our dy dt, or dy dx.
Right here.
Yeah.
Yeah, it was a negative 3t to the 2/3, and it says, what is it at t equals 1? So I plugged 1 in there, and I got a negative 3.
We're still doing it at t equals 1, not t.
So, well, because we got this. We got dy dx is equal to a negative 3, correct? Right? So if I look at this, this indicates, since this is a constant, y is a what? In other words, what would be the antiderivative? Y equals what? A negative 3x, correct? Which means that would be the tangent line, you know, the slope of that tangent line. So it means at that point, at t equals 1, there's no change, correct? Excuse me, there's no concavity. Yes?
Wouldn't it be over dx? Okay, that works too.
Which means at that I have no concavity at that point.
Can you get an equation for the second derivative?
The second derivative would be 0.
T equals 1, but can you get like an equation just for the second derivative the same way you get it for the first derivative? Or no?
Well, okay, so let's say I put, let's see, what would be another one? Let's put 8 in here. Okay?
Mm-hmm.
If I put 8 in here at time 8, what do I get?
4.
Well, I would get the cube root of 8, correct?
Yeah.
2 squared is 4, I'd get a negative 12,
Yeah.
correct? I get negative 12. And if I take the derivative of that at time is equal to 8, again I'm going to get 0, aren't I? For dy dx.
Oh.
Okay. All right, let's take a look at this one. And I think we're at Cole. Cole, this time our parameter is theta. Okay? So tell me how to figure out dy dx. What's the first thing I'm going to do? Right, so it's going to be dy d theta. What is dy d theta?
Negative theta over 2 e to the negative theta over 2.
Well, theta is a variable, correct?
Yeah.
So this is the same as y equals e to the negative 1/2 theta, correct? So it's going to be a negative what, did you say?
It'd be 1/2.
Negative 1/2 e to the what?
Negative theta over 2.
Negative theta over 2. Okay. What would dx d theta be?
That would be 2
E to the theta. Very good. So what is dy over dx? We don't have to simplify it first. You could just tell me what to put where.
would just be negative 1/2 e to the theta over 2 over 2 e to the theta.
Okay, would you agree? And that becomes what? Is there a negative 1 on top? Okay, what's on the bottom? Well, I have e to the theta, correct?
Yeah.
Times e to the theta over 2, correct? Because it's negative. Doesn't this 2 also go on the bottom? In other words, 1/2 divided by 2 is what?
1/4.
Right, so there's my 1/4, or negative 1/4, okay? Can I combine these? What do I get when I combine them?
4e.
This is 1 theta plus 1/2 a theta is what?
3 theta over 2.
3 theta over 2. Very good. And I think, so this is the slope, right? And I want to know what the slope is at a particular theta. So if I put theta into, and it says theta is pi over 4, I'm going to get a negative 1 over 4e. Oh, if I put pi over 4, what do I get? I get 3 pi over 8. Something ungodly ugly. But I don't care. I'm more worried about the sign, right? Because that's what the first derivative tells us. And this thing is always positive, and this thing is always negative. So what does that tell us about y, or our function? It's what? Yeah, function is decreasing. I think it's decreasing all the time, isn't it? Because whatever I put in for this exponent isn't going to change whether that's positive or negative, right? And there's always that negative 1, and that's not going to change. So this function's always decreasing, correct? Tristan, we're going to figure out the second derivative. So you have to take dy dx and take its derivative with respect to theta. And that's how we write that. Yeah. I'm going to back up a little bit, see if that helps. Can you see it okay, Tristan?
Yeah.
So Tristan, here's this. It's way over to the right. And I'm going to write it this way. Negative 1/4 e to the negative 3/2 theta. Are you okay with that?
I wrote it as 4e to the 3 pi over 8 to the negative 1.
Yeah, but this right here you did?
Yeah.
Well, that's that only if I put pi over 4 into there. This is my general dy dx.
Yeah,
Is
that's what I meant. Yeah. Can you do that to the negative 1?
okay, you have to say it again because I
Could I do 4e to the 3 theta over 2 to the negative 1? Could I do negative?
oh, let me write that down. 4
So you'd have to
e to the 3 over 2 theta. All of that to the negative 1
yeah,
power?
you have to make it negative. So
What?
make it negative.
For us to be negative.
Yeah, if
The
you
entire quantity is negative. So.
Oh, so this is negative right here.
Yeah.
Yeah, I don't think there's anything wrong with that. Okay.
What the exponent would be.
What are you going to do with that in that form?
So I just do. I'll just make it positive.
What are you going to make positive?
You just multiply the thing by negative 1.
Oh, okay. So you're doing this. Okay, let me follow along here. Negative 1, negative 4e to the 3/2 theta. Then this is a negative 2. Okay. And then you're going to come in here and take the derivative of this.
Yeah.
And what is that?
Maybe negative 6. E to the half. 1/2 theta.
No, you got to keep this the same. 3/2 because it's e, right? Times 3/2. Already did that. That's how you got a negative 6. Sorry. What did I get? So what is this? So this is 6, correct? This is negative 4 e to the 3/2 theta squared, and up here I have e, this one, to the 3/2 theta. This is 6 e to the 3/2 theta. Say this what? Say this again. Are we doing something wrong?
No, he's just saying that Tristan's way is a little bit more
So much
complicated.
I think this is a lot of work. E 3 theta. Wow. Can I show you a different way?
I'd love to.
Okay, this is all I did. I took a negative 1/4 e to the negative 3/2. You're going to get the same thing. Okay.
Yeah, that works out.
What?
That works out.
That works out. Yeah. You see how you get 3/8 here?
Yep.
And then you're going to subtract the exponent, and you're going to get 3/2 in the bottom. We're going to get the same thing. Okay? So I wrote that, and I got theta here, and then I take the derivative of this and get a negative 3/2. Okay? And this is 3/8 e to the negative 3/2 theta. Now, we got to divide that by something, right? We have to divide that by dx d theta. And dx d theta is right here, 2e theta. So I got 2e theta. equals, well, what's 3/8 divided by 2? This is a norm, so you got 3/8 of an inch, right? You divide 2, you got it cut in half. You get what? I think I heard it.
Something 16.
3/16. Okay? I did that on a piece of paper, okay, and I'm like 10. Because I'm proud. I'm working in my dad's shop. And I get a piece of, he says, what are you doing? I said, I'm taking 3/8. I'm cutting it in half. And he looks at me in horror. He says, just double the denominator. It's 3/16. Half of 3/16 is 3/32. Half of 3/32 is 3/64. Half of 3/64 is 128. That's what he says to me. He says, I'm paying you $0.25 an hour. I'm not paying you to think. Okay? I had learned my lesson. Next job, he comes up to me and says, what you doing? I said, I'm doing this. He says, what were you thinking? And I got confused. Because I'm not getting paid to think now. Watch what you say. So you get 3/16, correct? Then, what is this going to be? It's going to be e to what power? 5/2 theta. Now, I could put pi over 4 in here and get a number, correct? But this denominator will always be positive, correct? This numerator, because it's 3, will always be positive. That means this is function is decreasing, but it's always what? Yeah, f is concave up. The biggest thing is you can't forget to divide by dx d theta. Yes, sir. You're looking at me.
Is it a function? Or
Well, I'm going to say graph. I'm not 100% it's a function. I threw that out there and I'm going, oh, I hope they don't catch me on the function thing, but you caught me. Thank you. I did in my original notes say graph. But Jake was so happy with the word function, I thought I'd go with it. Okay? Because sometimes I just do things that make people happy. I know that my department would agree with that. Okay? All right, my favorite question, Jake. Equation of a tangent line at the given point on each curve. Okay? And guess what, Jake? I gave you a point. We're almost done. Right? Remember these? X minus 3 minus 2. Right? If I put 3 in there, I get a negative 2. That's what I want. I just need the what? The slope. Okay, so we're going to figure out the slope. dy dx. I'm first going to figure out dy dt, or you're going to figure out dy dt. Correct? What is dy dt? 3t squared plus 1, right? And over dx dt, which is what? 4t cubed. And I'm ready to go. I just need what? I want to figure out the slope, right? What do I need?
Do we need that in terms of x?
That, or I need a t, correct? So how can I get a t? You want me to give you a hint?
Sure.
Okay, x is 3, so I can say 3 equals t to the 4th plus 2. Would you agree with that?
Yeah.
Because x is 3. So 1 equals t to the 4th. And I'm going to say this for you so you don't embarrass yourself. Poop. Why did I say poop? Because I didn't want to say the other word. Why didn't I want to say the other word? Because what can t be? Yeah, plus or minus 1. I don't want plus or minus 1. So what I'm going to do is I'm going to use this equation now. And I'm going to say a negative 2 equals t cubed plus t, correct?
Yep.
And if I choose a 1, a good choice? Will 1 work here? No, because if I put a 1, I get a 2. And it's got to be a negative 2. So now I'm going to put in my other choice, which you said was a negative 1, correct? So I'm going to plug a negative 1 in there. Will that work?
Yes.
So t equals a negative 1. So the moral of that story is you both have to solve for the x and the y. Does that make sense to everybody? Now that I got a negative 1, I can plug it into this baby.
Yep.
What do I get when I plug a negative 1 into there, Jake?
You get negative. You get 4 over negative 4.
Which is a negative 1, right? So there's my tangent line. Everything going okay? Jack Rubinski. The equation of a tangent line given at the point on each curve. Ooh, theta. I need to know dy over dx, right? Notice I give you a point. Thank you, Mr. Kruger. I can do this. So, what's the first thing you're going to do here? Figure out what goes on top here, right?
Yeah.
You're giving me that look.
Go look.
Like you're afraid. You're not afraid of anything. You jump from tall buildings into water. I'm expecting a YouTube video of you jumping off a cliff and doing, like they used to do on a show called Wild World Sports. You got to figure out dy d theta, right?
Yeah.
So you can take the derivative of this with respect to theta. What are you going to get?
2 cosine theta.
Yeah, 2 cosine theta. Now, down here is going to go dx d theta, correct?
Yeah.
What's dx d theta?
3 sine theta.
Did you say 3 sine theta?
Is it? Yeah, I think so.
Correct? Okay. So we have to figure out cosine theta, sine theta, right? You know what I always go to when that happens? I go to this little thing. You know what that little thing is called?
Triangle.
What kind of triangle?
A right triangle.
A right triangle. Now, do you know why this is 2 and this is 5? Because this point right here is 2 comma 5. This point right here is 0 comma 0. Is that making sense?
Yeah.
When you plot a point, you go to the right and up 5. What's this diagonal length?
Square root of 4 plus 25.
Yeah, what is that?
Square root of
29. Are you opposed to the square root of 29?
Yes.
Well, we'll get rid of it for you. Okay. What's the cosine of theta?
2 over square root of 29.
You're talking slow like you're nervous. What is the sine of theta?
5 over square root of 29.
So now, we have this. We have 2 times the cosine, right? I'm going to draw my little arrow here. Are you okay with that?
Yeah.
Okay. So 2 is 2 over 1 times 2 over the square root of 29. That's 2 times the cosine of theta. over 3 over 1 times 5 over the square root of 29. You didn't like the square root of 29, did you? Okay, do you see how I'll get rid of it? See, it's gone. Do we have something you like a lot better? It's just 4 over 15. 4 over 15. See? Square root of 29 is gone. Cooper, there's something I did not do well.
It's that last step.
So do you see how you get 4 over the square root of 29? Right? 2 times 2 is 2. And then over here I get 15 over the square root of 29.
Yeah.
So multiply by the reciprocal. He didn't like them, so I had to figure out a way to get rid of them.
Yeah.
And I used math. Yes, sir.
Why do we need to do the whole triangle thing? In the last one, we just plugged in the points into the functions.
We could have done it that way.
Okay.
If I would have put 2, yeah, I guess that would have been a lot smarter way to do
Well,
it.
mine came out kind of weird when I did that. I got like theta equals pi over 2 or something.
Well, yeah, but then what does cosine of that equal?
Okay.
You know what I mean?
Cosine pi over 2
Or, well,
would be 0. Or
Oh, I see what you did. You put 2 into here.
yeah, that's what I do.
and that's why I see how you got your answer, but I'm wondering why my answer is different.
And why your answer doesn't work. Is that your question?
Yeah.
You would get the cosine of theta being 0, correct?
Yes.
And that happens at pi over 2, correct?
Yes.
So you would have theta equals pi over 2.
Yep.
And then, let me write this
That
down.
works for the y one too.
Or it could be 3 pi over 2. Is equals 0.
No, that won't work for the y.
Oh,
Also,
okay. You already checked
when
that.
you plug it in,
Theta equals pi over 2. So if you,
Plugged it into the dy dx thing, and it came up as 0.
yeah, so it's not working here, is it?
Yeah.
Because you get a slope of 0.
Yep.
I will have to investigate that. That's a good question. Okay. All right, arc length. So you've seen this kind of formula before, remember? The only difference was it was 1 plus the derivative squared. Well, now what it is, it's dxt squared and dyt squared. All right? So I'm going to go back in time. I'm going to have Maggie and Nevaeh work together since you were able to get a picture taken. Did you smile at your picture?
well, like, the microphone one.
Did you really?
Yeah.
Okay. So dx dt, what is it?
2t. We call t. Right? Yeah.
12t, right?
Yeah.
And Nevaeh, what's dy dt?
60.
The slope of 2, 5 should be 0, right?
Can I come back to that?
Yeah, I know, but it's ellipse. Okay.
Is it an ellipse?
That's nice.
Okay, let me take a look at it and I'll come back to it. Okay?
I was curious.
Yeah, I do not know what I did wrong on here, so I'll take a look. Okay? Oh, I know exactly what I did wrong here. Well, let me think about it. Okay. I'm going to put an asterisk by here. I'm going to write Nevaeh here.
Oh my gosh.
Way to go.
Wait, what do you mean? Wait. Hold on. Why am I in trouble for this?
In case it makes you angry. And
It
I'm going
doesn't take much.
I know, that's why I'm going to make sure that you're not armed when I talk about this again. Okay? Just saying.
Chop them off.
Okay, dy dt, what is it, Nevaeh?
16. Squared.
squared.
Thank you.
Okay? So that means we're going to integrate from 1 to 4 of the square root of 12 squared plus 6t squared dt. Claire, what is 12t squared?
144 t squared.
Okay. What is 6t squared, Claire?
36 t to the fourth. Next to 6.
Thank you. I did that just for you. So Cooper, what I'm going to do is I am going to factor something out.
12.
Yeah, what did I factor? I didn't factor 12. I think I factored 4 t squared. Okay, and I'm going to tell you why. Because I can take the square root of 4t squared. And here I get 9t squared and 144. I think you get 36. Can you see that back there okay? Renee, can you see that okay? Okay. And so that's going to give me 1 to 4.
Have you pull out an additional 9 on top of that?
Pardon?
Have you pull out 9 as well?
Yeah, you could
Yes.
probably
Yeah,
say
36
36.
you could take out.
Oh, I
Just
could have.
from the start.
Oh, let's do that. That's not the way I did it, but okay. It works. I got room. So then do you get 4t squared?
1 plus
4 plus t squared?
Yeah.
Yeah.
Like this? Yeah, that works. So then can I do this? I see people nodding. That's fine and dandy. So can I do this? Austin, if I'm going to reverse the power rule here, I need a 2t. Do I have a 2t?
Where's the 6 go?
Well, I'm gonna tell you in a second. Do I have a 2t? There's a 2t in there, isn't there?
You have 2 T.
And then I'm going to bring a 3 out here. There's the 6t.
Okay.
Because this allows me to do the antiderivative, right? Okay. And so I'm going to get 4 plus t squared to the 3 halves power. And over here I'm going to have 2/3. And I'm going to multiply that by 3, and I'm going to evaluate it from 1 to 4. I don't believe I did anything wrong there, but the way things are going today, there's always a possibility. So I'm going to have 2, and I'm going to put what in there? 4 first. One squared is 5. 1 squared is 1 plus 4 is 5. And I believe when you do that, you're going to have 2 times 20 to the 3 halves power minus 2 times 5 to the 3/2 power. And that equals some number. I think you get 156.524. Was that right?
Yeah.
Okay.
I think so. That's what I
All right, surface of a revolution. I made one little notation. You can revolve it around the x-axis. So you can see this is the arc length right here. And this is very similar to what we did in rectangular form. The only difference, there was a 1 here, and it was dy over dx. And over here was some type of function. This right here, if you're revolving around the x-axis, g of t is equal to y of t, which you'll be given. Likewise, if we revolve around the x-axis, f of t is equal to x of t. So Jack Lukanen, what's dx of t? We're doing example 6, the very last example.
dx dt?
Yep,
Okay. 1/2 t.
1/2 t. And what is dy dt?
1.
So that means that I'm going to set up my integral from 0 to 3. I have 2 pi. This is going to be y of t, so I have t plus 3. And I'm going to have the square root of 1/4 t squared. I don't know why I put in parentheses, I just did. Plus 1 squared. I could not simplify that, and I spent a lot of time trying to do that. This is what I did. I wrote this as t squared plus 4 over 4. I think you're okay with that? So I thought I was going to be able to go somewhere with that, and I had 2 pi, 0 to 3, and then I had t plus 3 times over 2 times the square root of t squared plus 4, because that's the square root of 4 in the denominator is 2. And I thought I could go somewhere with that, but I couldn't. And after working on it for a couple hours, not realize I didn't want to go to trig substitution or anything like that, because that's stuff I haven't talked to you about, and you don't have to worry about it on the AP exam. So I did it on my calculator. And what I did on my calculator, I got, not that, I got 89.10 square units. I like the first one because I was able to do that, but this one, nothing came really easy. So tomorrow and Thursday are work days, is that correct? And then we have a quiz, so stuff is due Friday. That seem reasonable? Okay, and if you don't know, the try got extended by 2 days. So after this, we're going to talk about vectors. It'll be okay. It'll be fine and dandy. Okay. And then we're going to talk about